All right, this video is about simplifying and simplified form. So definition, an nth root is in simplest form when there is no factor in the radicand, this is stuff inside the radical, that is a perfect nth power other than one or other than just one. The trivial one of the trivial ones. So here's some examples of things that are not in simplest form and things that are in simplest form, just for compare and contrast, right? So the cube root of 81 is, 3 times the square root of 81 is not in simplest form because 81 is a perfect square. It's 9 times 9. So it should be 3 times 9, 27. Square root of 5 times 4. I put in purple the perfect square that should be simplified, right? So there should not be a square. In simplest form, there should not be a perfect square inside the square root. Okay, so so the 4 is the problem there. The thing that should be simplified. 2 times 3 times 4 times 49. Both the 4 and the 49 are perfect squares, so that's not in simplest form. 27 times the cube root of 2 times 8. 8 is a perfect cube. So, and this is cube root, right? So a perfect cube, and so that's not simplified. Right? Cube root of negative 27 times 4 times 25. Negative 27, the cube root of that is negative 3, so that's a perfect cube. And 125 is 5 cubed, and so that's not in simplest form. There's a fourth root. Fourth root of 16 times 625. 16 is a perfect 4, it's 2 to the 4th. And 625 is 5 to the 4th, so that one's really not in. That'll actually simplify to an integer. And then one with a fraction, square root of 4 times 2 over 9. The 4 and the 9 are perfect squares, and so that's not in simplest form because the index is 2, so square root, right? So 4 is 2 to the 2, and 9 is 3 to the 2, and so not in simplest form. Simplest form, examples, 3 times the square root of 2 times 3. Now, in your answer, you would probably just write 3 times the square root of 6. I've just factored it so you can see that those factors are not perfect squares. Square root of 5 times 7. 5 is not a perfect square. 7 is not a perfect square. 2 times the cube root of 49 times 5. 49 is 7 squared, not 7 cubed, so that's not a perfect cube. And 5 is not a perfect cube, so that's simplified. It's in simplest form. Fourth root of 27. 27 is 3 cubed, so it needs another 3 in order to be a perfect 4, right? Another factor of 3, but it's only 3 cubed. So, so that's simplified. There's no perfect 4th powers in there. Cube root of 4 times 3 over 25. 25 is 2 squared, but not 2 cubed. 25 is 5 squared, but not 5 cubed. Right? And 4 is 2 squared, but not 2 cubed. And of course, 3 is not a perfect cube. So this is why you need to know those perfect squares and perfect cubes and perfect 4th powers that I had listed. Yeah, usually these are multiplied out when you see them. I just factor them so you can see the various parts, that they're not perfect squares or perfect cubes or perfect 4th powers, or whatever the case may be. Okay, so there's some rules for simplifying radicals. First, these are rules that we can use to simplify radicals, okay? So the nth root of a times b equals the nth root of a times the nth root of b, and then the second one, the nth root of a over b equals the nth root of a over the nth root of b. Now notice that's for times and divide. It's not for plus and subtract. Those don't work for plus and addition and subtraction. But anyway, so this works for all real numbers if n is odd. That's a cube root, fifth root, seventh root, etc. If n is even, you have to make sure that the radicand is positive or you won't get a real number. In fact, if n is even, we require that both a and b be positive. Otherwise, or positive or 0. Well, a could be 0, b can't be 0. I'm not sure why I wrote it that way, but a has to be greater than or equal to 0, and b has to be greater than 0 in the second one, because you can't divide by 0. And the first one is greater than or equal to 0. But anyway, they can't be negative is what I'm trying to say here. So, for example, cube root of negative 8 times negative 1,000 equals the cube root of negative 8 times the cube root of negative 1,000, which is negative 2 times negative 10, which is 20. Now, usually you wouldn't do it this way. You would just look at this and you would just say, oh, negative times negative is positive, so this is the same as the cube root of 8 times 1,000, which is 2 times 10, which is, so you would get rid of the negatives first. But I'm just showing you, you could split these apart with the negatives and it still works. But it doesn't work with square roots or fourth roots or sixth roots, any of the even indices. If you had square root of negative 4 times negative 100 and you tried to split those apart like this, that's going to be wrong. It's going to turn out to be the wrong sign. It'll turn out to be a negative number. But the main thing at this point in the course is that these are not going to be real numbers. Square roots of negative. Remember the domain of the square root function, x is greater than or equal to 0. So anyway, those don't work. So how would you do this? Well, you would take and cancel the negatives, right? It's negative times negative is positive. And so you just have square root of 4 times square root of 100, just like you probably would have done here anyway. So my only point is this doesn't work if a and b are both negative and the index is even because of this business. So this is how you would actually do it, right? So you can still get an answer on this. You just have to do it the right way. Okay, square root of x squared is absolute value of x. Think about it. If you put in a negative number, put in negative 2 for x. You square it, you get 4. And then you take the square root, you get 2. You don't get negative 2. Your original number was negative 2. If you just had an x here, it would say 2. Right? Well, the x is negative 2, but this quantity is actually positive 2. So that's why the absolute values are there. I have a note on the next page about that, though. Right? So it doesn't simplify if that x is negative. It doesn't simplify to just x. But we have a way around that, and I'll talk about that on the next video.